Alright, thank you for joining me everyone. My name is Yakubu Adam Ibrahim. So we'll be talking about SQL in data analysis. So this video is really going to be helpful to you if you are aspiring in the field of data, maybe data scientist, a data engineer, or a data analysis. So or you are a particular person working in a particular organization that needs SQL. This video is really going to be helpful to you. So I do recommend you watch this video from the beginning to the end. So we'll start with what you understand as programming language. Programming language is just like the language I'm speaking, like the English language, like the French language, like Germany, like Hausa, or and so on like that. So it's actually a way for programmers to communicate with the computer. That's all. And programming language is actually a written set of instructions provided to the computer to get the desired output. That is what programming language simply means. And for sure, for you to speak a language and for you to communicate to someone, you need to understand the syntax and the grammar. So that's just about programming language. So I'm talking about four types of programming language. The first one is the procedural programming language, and some examples of procedural programming language are the C++, the Javas, and so on like that. We also have the functional programming language. We have the object-oriented. Examples of the object-oriented are the Python, the R, and others like that. We have the declarative language we'll be talking about today. So SQL actually falls under declarative programming language. So when I'm talking about declarative programming language, it actually means programming language that's actually focused on the output rather on how you attained that result. So the creative program is all about the output, not how you have achieved that result. So you can actually get the result differently, but the output is the most important about declarative programming. An example of a declarative programming language is actually SQL. About programming language. What is programming language? What does it really mean? So programming language is simply like a language, like English language, Arabic language, French, German. That's how programming language simply is. It is nothing but that. So programming language is a set of written instructions provided to a computer to provide a desired output. So it's just a normal language you are used to. And so basically, to know how to use a programming software, a programming application, all you just need to do is to learn the language. So, and here we'll be talking about SQL. So SQL is also one programming language which you need to learn if you want to become a good data analyst. So as I said, it's actually language. It's actually written instruction provided to a computer to provide a desired output. So that's simply what a programming language simply means. So we have different types of programming language, and we have four here. So which are: one, we have procedural, which you can as well known as imperatives. Then the second one is declarative, or you call it non-procedural. So and a type of programming language, a programming application or software that falls under declarative is SQL, which we'll be learning today. So the other one is the object-oriented. Other examples of programming language that fall under object-oriented are Python and R. So these are also some tools used in data analysis. Then the fourth one here, we have the functional programming language. So these are the basic common four types of programming language we have. So why do you need to learn SQL? What's SQL and why do you need it? Why SQL in data analysis? So SQL simply stands for Structure Query Language. It is sometimes called SQL. So whenever you hear SQL or SQL, they mean the same thing. So don't get confused whenever you hear those words. SQL and SQL, they are the same thing. So and it stands for Structure Query Language. Okay, then why should I learn SQL? SQL, as I've said earlier, if you have been following along, SQL is a declarative programming language used to retrieve data from database. Majority of today's business companies stores their data in database for security issues, accessibility, and many more. More importantly, SQL perform CRUD operation. So what's CRUD operation? You get to know as we move along. So in order to retrieve our desired data from database, we need what we refer as a DBMS. So what's a DBMS? A DBMS is a special software program that helps users create and maintain a database. It also makes it easy to manage large amounts of information. It also helps us to handle securities of our data, the backups of our data, importing and exporting our data, and fact concurrency. Then it also helps us what interact with software applications, e.g. Power BI. So we can actually import whatever data that has been stored in the database to Power BI through a database, a DBMS. So that is what we mean by interacting with software application. So as I've said, SQL is simply used to retrieve data from database. So and SQL is a language, as I think I've said earlier, that SQL is a programming language to retrieve data from database. So majority of today's business or companies, they store their data in the database for security. So for you to access or to retrieve a particular data from any database, you need to learn SQL. So then, and after learning SQL, you need to have a particular DBMS where you would apply the SQL or the programming language, which it is simply SQL, to retrieve that data from, which is referred as a DBMS. So we heard about CRUD operation. So what was CRUD operation initially? So what a DBMS can do? So it can actually do CRUD operation. So I talked about SQL performing CRUD operation initially. So this is what it means. So C stands for creating, R stands for reading, or you say retrieving, while U stands for updating, then D stands for deleting of data from database. So creating a database, reading or retrieve data from database, U for updating data in the database, and D for deleting a particular data from a database. That's what we simply mean by CRUD operations. So what is a database exactly? Because you'll be hearing me talking about database, you might be a little bit confused. So this is what we mean by a database. A database is any collection of related information, e.g. your phone book, your shopping list, your to-do list, your 5 best friend, your Facebook user base. So I'm sure you all must have had one or two notes back in secondary schools, or even in your tertiary institution you must have had notes. So the book itself is a database because it contains related information. You have a particular note for mathematics, for social science, and like that. So that note contains related information, related topic. You usually have related topics, logical topic, like that. So interrelated. So they are basically a database to the simplest form. So your phone list, your contact list, you have different contacts. On your phone. So there is actually a database as well. What you want to achieve today is also after writing it down, is also a database as well. So those are the simplest form of what a database simply means. So, and where database can be stored. So database can be stored in several places. So example is okay in your mind, on a computer, this PowerPoint, a comment section, maybe a Facebook comment section. So there, everyone is making comments. It's also a database. So that's also an information that has been stored under the comment section. So but our focus in this presentation is storing a database on a computer, the modern way. So what's the difference between a database and a spreadsheet? A database is simply used for storing and keeping track of data, while a spreadsheet is used for extensive analysis alone. Though a spreadsheet can keep data as well, can store data, but it is made for analysis. So even a database can as well do some little analysis, but that is not the specific purpose of having a database. So a spreadsheet can as well store data, but in terms of the below, a database is best in terms of retrieval of data, updating of a particular data, the data efficiency, data consistency, integrity of the data, speed in accessing that data, security issues of the data, and the data storage capacity. So database has a very large volume of storing data. So that is the purpose of having a database. So then while a spreadsheet is simply for analysis, an example of a spreadsheet is simply Microsoft Excel. So an example of where a database can be stored is Oracle, MySQL, Microsoft Access, PostgreSQL. So example of a spreadsheet too is simply Microsoft Excel is the common one. So let's move ahead. So what is a DBMS? I think I've explained what the DBMS simply means. So here we'll be talking about the types of DBMS. So we have two types of DBMS. We have the relational database and the non-relational database. So relational database is simply where you use SQL. Why non-relational database is you don't use SQL for a non-relational database. So what's the difference between an RDBMS and non-relational database? So RDBMS simply stands for relational database, while NRDBMS stands for non-relational database. So RDBMS organizes data into one or more tables, while non-RDBMS organize data into anything but a traditional table. Basically, a database, a data analyst simply work with a relational database. So they work with relational database. So other professionals in the field of data, like data scientists, data engineers, worked with non-relational data. So I'll briefly explain what we mean by non-relational data with a particular picture which I have for you. So each table has rows and columns and a unique key identifiers rows. So each table has rows and columns and a unique key identifier rows. So in non-relational DBMS, we have key values, documents, graphs, and flexible tables. So basically, as I've said, you don't, as a data analyst, you don't need to focus more on the NRDBMS, which is non-relational database. You need to focus more on the relational database management system, because that's what you work with as an analyst. So it also helps user create and maintain a relational database. Why non-relational database helps users create and maintain a non-relational database like MongoDB, DynamoDB, Firebase, and like that. So those are examples of a non-relational database. So it performs code operation as well as other administrative tasks. We have users management, security, backups, and so on like that. So most non-relational database will implement their own language for performing crude and administrative operations on the database. What's the difference between SQL and MySQL? A great example of RDBMS is MySQL, and it is not limited to that. We still have Oracle, we have PostgreSQL, MariaDB, and a lot of them like that. But these are the common ones. So what is the difference between SQL and MySQL? So SQL is simply a language. SQL is simply a query language which can be used to write different queries and commands in order to access a database. So what is MySQL? MySQL is just like the software itself, where you apply the language you have learned. A lot of people interchange this SQL and MySQL together, so they interchange it often. So MySQL is a relational database management system, RDBMS, used to manage different databases. So SQL is the language, while MySQL is the RDBMS, or the application where you apply SQL, then you get your data from it. So to use SQL, you need to learn the basics like grammars and syntax. No such prerequisite to use MySQL. It's just a software to use. So SQL is used by Oracle, MySQL, PostgreSQL, MariaDB, etc. Also have Microsoft Access, while MySQL is a relational database system on SQL. I hope this difference is clear. So what do we mean by query? What is query? What does query simply mean? Query simply means questioning. When you ask for something, it's simply a query. So it is a set of instructions given to RDBMS written in SQL that tells the RDBMS what info you want to retrieve for you. So the goal of querying is to get the data you need. So query is just to ask for something, requesting for something. So requesting for a particular data you need for your analysis. So that's the application. So a Google search is a query. So me going to Google, questioning it, okay, I need some data, I need that, okay, what is this, what is that? I'm actually creating this Google search engine. So what is also a schema? There's what we refer as a schema. A schema is a layout or architect of your database, just like a your building foundation. So we'll be moving to the different type of SQL command. Basically, we have 4 SQL commands. So the first one here is the DDL, which stands for data definition language. So data definition language is simply used in defining and creation of database. So creation in this commands in these categories are, we have create, we have alter, we have drop, we have rename, and we have truncate. So as we move along, I will show you how to use these commands in the practical aspect of this presentation. So we also have a DML. So this stands for data manipulation language. Data manipulation language is simply used for manipulating a database, and examples of the command under data manipulation language is we have insert, update, delete, and select. So don't forget, when we get to the practical aspect, we will see how it works practically. Data control language, which is this here. This is used in granting and withdrawing access to the accessibility of a database. As we all know, a database isn't used or accessible to one person, business, or individual. We have 2 commands here, which is grant and revoke. So we also have TCL, which stands for transaction control language. So this is used for storing or updating data in database permanently. Sometimes most of our data will make changes of or insert or update and delete, that's a DML command, in the database don't reflect permanently for other users. So we have 2 commands here, which is commit and rollback. So we also have some key difference in some of these commands I have made mention. I have made mention of delete, I have made mention of drop, and I have made mention of truncate. So here is a difference between them. So simply because I have not used this command, so I think you would not get this difference right away from here. So you've not seen a practical aspect of how these commands work. So these 3 commands are similar, but they are different. So I have made mention of them. This is actually a DDL. This is also a DDL. I think this is a DML language. This is also a DML, and the difference are there. So it's written in the second row. Delete is a DML command. It's part of the DML command I listed initially. Then drop is a DDL command. So, and while truncate is also a DDL command. So there is a mistake in this presentation here. So drop in the DDL command, and truncate is also a DDL command as well. So that means I think I'll be coming back to this after showing the practical aspects in this presentation. I pray time permits me to do that. So let's move ahead. So there's what we also refer as tables and keys. So tables and keys is one important concept you need to know when learning SQL or when using SQL. So a table is any organized data that has rows and columns. A table stores information in rows and columns. Example is what we have above, where we have column 1, column 2, and column 3. Nothing changes. It's simply how you have known a table to be. Nothing is changing there. So then what do we refer as a key? Okay, there are a few things we need to note before we move into keys here about a table. So each value in a table is known as a data table. A particular value you have in a table is known as a data table. Then each value or data value together in a role is called a record. That's a particular role in a table. Let's say row 1 or row 2, for instance, in a table is referred as a record. So a column in a table containing specific information about every record in a table is called a field. So we're talking about a particular column here in a table here, so it's referred as a field. So whenever you hear of record and field, record is simply a role, while a field is simply a column. So when your data is stored in an organized rows and columns, it means you are dealing with a stored tabular data. So a few related tables forms a relational database. The smallest unit that can contain a meaningful set of data is called an entity. So hence rows represent horizontal entity or entity instance, while columns represent vertical entity. the table can be referred as an entity on its own or database object. So basically what we have here is are some basic concepts or some terms that we make use of when dealing with SQL, when dealing with tables in SQL. So these are some basic concepts you need to be aware of when you are working with tables in SQL. So just please take note of this. So what is keys? I made mention of tables and keys. So what is simply keys here? So we have different types of key here. We have 6 keys listed. We have a primary key, the foreign key, we have the composite key, the super key, the candidate key, and also the alternative key. So I'll be making use of an image to explain each of these keys. Okay. Well, I'm making use of an image. I have an image stored here. Hold on, please. I'm coming. Okay, fine. Just be patient. Okay, so this is a table. What I think we must have seen similar table like this before. So it's just a table with the name of students, the student's ID, the name, and their major. So that is their course, or their discipline. So this is what basically what also refers as table in SQL. Nothing changes. So I want to use this table to explain what we refer as keys. So you will notice this. Look at this column headers. The header, the student's ID, it was painted red, and other columns were painted blue. So this one painted red, the student's ID, up. Is it red? This is pink rather. I'm sorry. So this one painted pink, the student's ID painted pink. It was painted pink to represent a primary key. So and I think you all heard primary key as part of the keys we have in SQL. So I said we have 6 keys. We have primary keys. So this is what we refer as a primary key. So what do we mean as a primary key? What is basically a primary key? So a primary key is simply anything number or text that differentiates every rule to the other rule. So for instance, we can see there is in this particular data, no student is having the same ID. So this is what we refer as a primary key. So primary key is simply that thing, number or alphabet or a name that differentiates a particular rule to the other rule. So we actually call it a uniquely identifier for a particular rule. So here, every record or rows of data here, when I'm talking about record, I'm talking about a particular rule, as I've mentioned earlier. So every record there is being differentiated with every number. So that differentiation is what we refer as what? A primary key. And why the other columns, which were painted blue, is referred as an attribute. So this is the primary key. That's for student's ID 1, we have the name as Jack, and we have major as biology. So these two, the name and biology and major, is what we refer as an attribute. Then this ID, this number that differentiates a particular record to another one, is what we refer as what? A primary key. So let's see the definition I have here. So what is a primary key? A primary key is a unique number, example matric number, or a text or string. So when we talk about string in programming language, string simply means an alphabet, like an alphabet, something like a name. So that's what, whenever you hear about string, it means text, like your name, your own particular name. That's what we refer as string in a programming language. So this is a unique number, that is matric number, like for example, or text or strings, for example emails, that uniquely identify a particular rows and columns in a particular table. Okay, so we also have two types of primary key. So we have the natural key and the surrogate key. So what do we mean by natural and surrogate key? So natural keys are keys that has a map or purpose in the real world. An example, we have the NIN, we have the BVN, we have the SSN, we have matric number. So natural key is simply key that is used, or a number, or in fact a serial number that is used to differentiate a particular thing from the other, even though they could have the same name, but there is that thing that differentiates them. For example, in the bank, we would have a lot of customers that bears the same name, but at the end of everything we have an account number, we have a BVN number that differentiates every customer to the other. So that's basically what we mean by the primary key. So it's just for a differentiation. So for we to have understanding of our particular data, that's why we have a primary key. So primary key is something needed for every data you would have, for you to have a clear understanding of it. So as I said, we have two types. So the first one is natural key and the other one is surrogate key. So a natural key is simply anything that's used for differentiation, but it makes sense. It is used in the real world, like NIN and like that. So the other one is the surrogate key. Surrogate keys has no purpose in the real world. It really has no purpose in the real world, like fabricated or just formed or assigned for that truth. For example, like this particular image, this is an example of a surrogate key. So because just for this data, they just had to assign 1 2 3 to every student, so it does not really serve any purpose. So this differentiation only serve a purpose for this table differentiation and nothing more again, unlike a BVN where the word or the part knows the purpose of what a BVN means, the SSN and NIN, like that. So those ones serve a real purpose in the world, and it also differentiates a particular person from the other. So but in this case, 1 2 3 is just used to differentiate. So it's an example of a surrogate key. So it was just formed just to, okay, just like you saying I have two particular people bearing the same name in my class. Then I just have to add okay, you are Zainab Big, you are Zainab that, so just to differentiate them. So that's what refers to what a surrogate key. Okay, so what's the foreign key? A foreign key, this is a key that can be stored on a database that will link us to another database table. In essence, a foreign key is another table primary key. So let me show you what we mean by a foreign key with a picture as well. Okay, so looking at this data, we have foreign keys and primary key in this data. So this is a particular company's database contained with employee details, their branch, the clients they have worked with, the branch they supply to. Okay, so in the first table we have the employee details there. So let's simply look at this table. Let me zoom it bigger. So we have employee 101, which serve as a primary key. If you notice, every number in that employee, in this employee first column, that's under the employee ID, that is painted pink, they are numbers used to differentiate every employee in that data. So that serves as a primary key. So every number, they uniquely identify a particular role in that data. So employee ID 101, the first name is David, last name Wallace, and we have birth dates, we have the sex and the salary. So these other two columns that is painted with green represents a foreign key. So what is the foreign key in this? What's foreign key? As I said, The other two columns here represent a foreign key. That's the super ID and the branch ID. So what is actually the foreign key in this column? So I want us to first understand something. Let's look at this particular data and let's see the essence of a primary key. Without this primary key, do you agree with me that this data would get, as more of employee would have, this data would get mixed up, rough, and we find it hard to understand it. And what's the goal of data analysis? Is to allow business be able to analyze and get some particular information about a very large data set, very large one, something that seems very confusing, data that is over millions. So it's to data analysis to allow business see some insight, see some information that they really can now get by looking at that data. So that's basically what's the goal of data analysis. So let's think about having this data and not having a primary key or having an employee ID. Would we be able to analyze this data? This data would because as more we keep employing people, we would have a particular employee that bears the same names. So then how do we differentiate them? So that's the essence of having a primary key. So with you having a primary key, whether the data is up to millions and billions, the data can be analyzed, and everyone can have a clear understanding of what's contained in that data. So, and I think everybody or every one of us would agree with me that in our schools we have a lot of people that bear the same name. So how do you get to differentiate them? So that's the essence of having a primary key. So we're now back to what a foreign key. So what's now the purpose of having a foreign key? So a foreign key is as I said, is another table primary key. So and it's a key that will link us from a particular table to another table. So if you look at this super ID, it stands for supervisor ID. So that means for David that has an employee 100, he has no supervisor ID for it. That's not. So nobody is actually supervising David, and is working in branch ID 1. So that's branch 1 of that company. That is where David is actually working, and he has no supervisor. So then for 101 we have Jan first name, then Levison for the last name, Beth, we have she is a female, so and salary of 110. Then the supervisor of Jan is actually David. So you can actually see that here. Look at, we have supervisor ID, which is 100. Then if you look at this employee ID, who is 100 here or 101, that's David. So David is actually supervising Jan. So David is actually supervising Jan. So look at 102, Michael Scott is a male, and who is supervising Michael Scott? That is David. That's 101, employee 101. So this ID we have in this place are ID that was picked from this place. So that's what we refer as a foreign key. So a foreign key is another table primary key. So it could be that same table primary key, and it could not. So it could be another table primary key, and it could be that same table primary key. So that's what we mean by a foreign key. So then let's move to branch ID 1. So this is the branch table. So we already have branch ID here, which is a primary key here. So branch ID 1, branch name, which is corporate. So we also have manager ID and the start date. Manager ID here represented in green is also a foreign key, and it's also actually looking up to the employee ID here. So we have branch ID 1 corporate and manager ID 1 100. So that's 100. That's David. So yeah, we can actually see this information that nobody is supervising David, and David is as well working in the corporate branch in this information. So yeah, this primary key here of the branch ID has been used as a foreign key in this employee table as a foreign key. So that's basically what we mean as a foreign key. So here is what is actually uniquely identifying a particular role in a table is what refers as a primary key. Then a foreign key is a primary key of another table that will link us to that same table. Or is that confusing? So in nutshell, we have 100 David, Wallace, birth date, sex is male, we have salary 250. So no supervisor for David, and he's working in the corporate branch. So with this information we have here, we also have 101 Jan Levison, the birth date she's a female, 110, and David is the supervisor, and she also work in the corporate branch, just like that. We have 102 Michael Scott, the birth date, the male, so like that. So even if we have billions of data, our data is organized and we really can understand this. So with this, the data analyst would not have any issues with that data, so they can really understand understand that data and analyze it, so and give a good report of it. So you need to understand how a table and a keys work. So I've explained the primary key and the foreign key. So just to the same thing to other tables here, we have the branch ID here is a primary key, and the manager ID here is a foreign key. Others painted in blue are attributes. So here is also a primary key, the client's ID, the client's name, the branch ID, like that. So we also have two primary key here. So I will explain what this serve as move ahead. So let's move to the next one. So one of other key you need to know very well is the composite key. So what is actually a composite key? This is a key that needs two attributes or columns to uniquely identify a row. No redundant attributes. No redundant attributes. Okay, let me show you what a composite key looks like. So this is the company database, and as it was said in this presentation, this is a key that needs two attributes or columns to uniquely identify a role. So as I've said earlier, in a primary key we usually don't have duplicate record. We usually don't have a particular entity or a particular thing having the same number or ID, for instance. So we usually don't have a particular thing having, or two different things rather having the same ID. So we usually have unique ID to a particular thing. So just like David 100, Jan 101, Michael Scott 102. So look at the branch as well. But there are cases whereby even the client's ID, there is no duplicate ID there. So every client's name has a particular client's ID. So just like every student having a particular matric number. So if you notice, even in matriculation number, even if the student has graduated, that particular matric number of that student is not assigned to anyone again, because the year would keep changing. So the purpose of doing this is to be able to retrieve every data that is related to that student since he was in that school. So that is the essence of having all of these primary keys. So what we are talking about, a composite key here. So since we don't give two things the same ID, but there are situations whereby in recording we would have two ID occurring twice. Looking at this now, this is, if you study this table, we have the employee table, thus every employee having a unique ID. Looking at this branch, we are having every branch having a particular ID. Looking at these clients, you have every clients having different ID. But looking at this work with table, if you study the work with table and the branch supply table, you notice under the employee ID we'll be having an employee ID like occurring multiple times, more than once. Like you can see here, employee ID 105 is occurring in the first row and occurring in the last row. So, and you notice that's that the purpose of the primary key would not be effective here. So because since I'm having a duplicate employee ID here, I won't be able to trace the particular total sales which that employee had sold. So now, so this is where the composite keys comes in play. So, and where are the situations where you'll be having what are the situations where you'll be having a particular ID occurring multiple times? It comes up particularly when you start recording, when you want to record. If you notice this work with and the branch supplier table, they actually record which a particular employee has taken or has performed in that business. You notice this is work with. So this table is simply okay, who that employee has worked with, or he has sold goods to, for instance, like that. So, and this branch supplier is simply what every branch has supplied, so that is the information contained in those two tables. So in the case of recording, you'll be having an ID occurring multiple times, because it's actually very logical, simply because when we're talking about working with, since this is a company, maybe they supply papers, or this is a manufacturing company. So definitely an employee will be working with different clients, so that is where you'll be having an ID occurring multiple times. So during the case of recording, an employee could perform more than 100 transactions in a day, could work with on more than 100 customers in a particular day. So in the case of recording, you'll be having, okay, this particular employee sold to this client, he came again, he sold to this particular client. So in case of recording, you'll be having the ID occurring multiple times. So there's a, since we'll be having that ID occurring multiple times, then to differentiate that particular transaction which that employee has made to a particular client or customers, we need to now have another primary key joined together with that employee. So even if the employee sold or made 100 transactions in the particular client, he would definitely be making that transaction to a particular person. So that person he made the transaction with and the employee, so their ID can be joined together to form what we refer as what a composite key. So that is what's simply happening in this place. So employee ID was combined with a client's ID. With that, combining these two IDs together, we'll be having a unique identifier for that transaction. So when you combine employee ID and client's ID together, you will notice that there is no match anywhere again in that same table that will be having, for instance, 105 and 400. Definitely one of them must change. Where we have employee ID 105 and client 400, you notice the last one is now employee 105 and client 406. So this is what we refer as the composite key. So composite key is simply used when you start having a particular primary key occurring multiple times. Then you need to differentiate it with another column, which is also a primary key, then to make that record uniquely identified. So that is what we refer as what a composite key. So the same thing I've explained here is what is simply happening in this branch supplier. Okay, so let's move ahead. So we move to the candidate key. So these other keys are not very common though, but you need to be aware of their purpose before we move to the next thing. I think we are almost done with this presentation. So we have you have the candidate key. So what is actually a candidate key? A candidate key is simply every key, or I'm talking about key, every columns that is having a unique value, which could be a number like a matric number, or a text, or your email. If you sign up a particular email, the your username is meant for only you. No one uses that same email again. So email is another example of a primary key. So what's a candidate key? A table can have multiple candidate key, minimal super key with no redundant attributes. So a candidate key, it's simply, any column that is unique all through in a particular data. Any column. I don't have the example here. Any column, that's what simply mean as a candidate key. A candidate key is simply any column that can uniquely identify a particular row, just like a primary key. So look at this table, for instance. Now this student ID is the primary key of this table. This student ID is the primary key of this table, and it's also the candidate key in this table. So a candidate key is simply any column that can uniquely identify a particular row. So that is what we mean by a candidate key. So let's say, for example, I'm trying to figure out an example which I have. Okay, I've got an example here. Look at this branch table. We have branch ID, we have the branch name, we have the manager ID, we have also have the manager start date. So we have two primary keys. We have two candidate key. We have two candidate key in this particular table. So the branch ID is a candidate key. Then the branch name is also a candidate key. What makes them a candidate key? They are candidate key simply because if you look at the column all through, there is no double entry, there is no particular value occurring twice. And looking at this branch name, there is no name that is repeated in that particular column. So I as a person, I can just look at this table and decide to pick a primary key. That is the one I will be using to differentiate my data. Like, since this ID do not have a duplicate entry here, the branch name do not have a duplicate entry, I could now pick any of them. Both of them are candidate key. So I could now pick one out of both of them to serve as my primary key. So a primary key is picked from a candidate key. So you'd have multiple candidate key. So that is every column that have unique values that can uniquely identify a particular row. Then after having multiple, you could have multiple candidate key and you could have one. So the one you have picked to use to uniquely identify the particular row is now referred as a primary key. So that's the difference between a primary key and a candidate key. So that means this branch ID and branch name are candidate key, and I could pick any of them to serve as my primary key. So that means I might not use a branch ID, I might use branch name to be my primary key. So in that case, so that means I could pick any of them to be my primary key. I could decide to use branch name to be my primary key instead of branch ID, but it is safer to make use of a number to be my primary key. So that's that. So let's move ahead. So we also said is a minimal super key with no redundant attributes. Let's see what a super key means. So a table can have multiple super key. A super key is a combination of all possible columns. That's candidate key. So candidate keys are all possible columns that can uniquely identify a particular row. So the one you pick, you then need to pick one to serve as your primary key. So a super key is a combination of all possible columns, that's candidate key, that can uniquely identify a row, redundant attributes, inclusive. So NB, composite key needs, these are the difference. This is a kind of differentiation between these keys concepts. So composite key needs the other columns mandatorily to uniquely identify the role because of duplicate ID that may occur in the first row. But super key is just a combination of all candidates key or columns that can uniquely identify a row. So let me briefly show you what you refer as super key. So since I said branch ID and branch names are candidate key, the combination of both of them, so every key that can uniquely identify a role is referred as a super key. Every combination, the combination. So we'll be seeing things like no redundant attributes and redundant attributes. So every combination of columns that can uniquely identify a particular role is referred as a super key. So that means the combination of both ID and branch name are super key. So and they try to differentiate the difference between a super key and a composite key. Yeah, the difference between a composite key and a super key is that a composite key is having a duplicate value in that particular column. So for us to differentiate that transaction, we need to have another column to make that transaction unique. So that's what we refer as a composite key. So that's what we refer as a composite key. So a composite key needs another column mandatorily to identify that role, but a super key is just a combination of every unique column that can uniquely identify a particular role on its own. So those are the differences. So the last thing we have here is the alternate key. So what is alternate key? So in this picture I said both branch ID and branch name are candidate key and the combination of both of them are super key. A composite key needs other column mandatorily to uniquely identify that record. It needs that column, but a super key did not need other column to uniquely identify that particular record. Each of the column that makes it a super key can uniquely identify that record. So those are the difference. So what's now alternate key? Since branch ID and branch name are candidate key and they form a super key, so and branch ID has been picked to be a primary key, then the other column that is left to uniquely identify a particular role is what refers as an attribute, is what refers as an alternative key. So the other column that is left is referred as what? Alternative key. So that's what we have in this definition here. So when a primary key is selected among candidates and super key, the remaining left can be referred as an alternative key. So we move ahead. So we also move to common types of data types you can have in SQL. So we have int, which is referred as an integer whole number. So you would get to understand this when we move to the practical aspect, and I'll show you how to make use of these data types as we move along. So we have the int, we have the decimal, we have the enum, okay, we have virtual stands for string. So as we move along, I would show you how to make use of this and you will understand them better, trust me. So a wrap up of what we've been saying so far. So a database is simply any collection of related information. So computers are great for storing database. DBMS makes it easy to create, maintain and secure a database. Database that's DBMS allows you to perform code operations and other administrative tasks. Two types of database. We have the relational database and non-relational database management system. Relational database uses SQL and store data in tables with rows and columns. Non-relational database uses other data structure. Notes: SQL implementation may vary between systems. Not all RDBMS follow the SQL standard to a T. The concepts are the same, but the implementation may vary. So what do they mean by not all RDBMS follows the SQL standard to a T? It means that since we have MySQL, we have Oracle as a DBMS, there are some command that you write on MySQL that is not acceptable in Oracle. There are some command you write, because okay, let's say programming language you write on MySQL, though they are all RDBMS, they are all RDBMS, but there are some commands you write to MySQL that is not acceptable in Oracle and some other DBMS like that. So that is what it means by, so not all RDBMS follow the SQL standard to a T. So not all of them have the same, have all commands. So though some of they have some similar ones that you can put up on MySQL and it also works on Oracle. So not all of them that works that way. So but basically the concept of all of them are the same thing, but the implementation may vary. So that's what we mean by not all RDBMS follow the SQL standard to a T. So let's move to the practical aspect of this presentation. Let me launch up my MySQL, and I want to believe you have downloaded and installed MySQL on your laptop, because that's what I'll be using for this presentation. Let's wait for it to launch. Okay, so please kindly always tell me how you feel. If you're having any question in the comment section, so I'll be glad to respond to them. Always tell me how you feel and what you have gained so far in the comment section. So okay, my MySQL has launched. Okay, so when you have installed MySQL on your system, so this is how the interface look like. So welcome to MySQL workbench. So then you'll be having this what we refer as a connection. So and this connection is something that would have you have done while launching this, or should I say registering MySQL before you get to this interface. When you install it, there are some questions that will be asked from you, then all those things, okay, you get up a connection like that. So then after that, so after having this interface, all you just need to work on MySQL is just click on that connection you have. So then sometimes you would have to provide it a password after clicking on that. So but I have saved my own as always remember me as Vault. So it's referred as Vault. So always remember me, so I don't have to always type my password again. So then I'm coming. Okay, let me open a new tab for this presentation. I'm coming. Hold on, trying to fix some things there. Let's see. Please just hold on. Okay. Okay, so after clicking on that connection, so you'll be having a blank interface like this, interface like this. So this is how it look like. So yeah, you'll be having file, you have a lot of things you can do that the file. You have new model, you have new query tab. You can click on this. Let's see, for example, to have another. You can see I can switch from files to files, that listed of files I have opened down here, or which I've been working on before now. So I can switch between files. I can look at, so it's actually working perfectly. So you can use the new query tab to add a new tab like this, so just like other ones I have here. So you have files, so you have the one thing you need to notice, what you whatever you have, maybe a file that you have written a code on is referred as a script. So that's what we refer as a script here. So open SQL script. So we're talking about scripts. Scripts is, let's say the file you have written your code on, maybe you save them, so they are referred as a script. So you can open the recent script, you can run scripts, you can run SQL scripts, close the tab, and like that. The other things that there you can do there. So we also have edit and some other options you can find there. So we have the find and format, maybe how to beautify your code you'll be writing. So how do you want to see them? And so you have the view. These are other things that you can just, these are tabs you should just try to visit. So like that. So yeah, moving to this place, this way. Okay, we have create a new SQL tab. So this is simply will be adding new tabs. So all these are referred as tabs. So we'll be adding new tabs. So yeah, is to bring in maybe a written SQL script you have in your laptop, maybe, or maybe a previous work, or when I'm talking about script, I think I've talked about that. So these are files you have your written codes on. So those are what files and so script. So you can bring in a particular script, maybe a colleague sent to you, or a previous work, or the one you've saved, or that just simply means a file you have saved. So yeah, we can inspect, you can inspect a selected object, you can create a new schema. A schema can be referred as a layout of a database, if you remember my presentation. So you can also refer to it as creating a database. So for you to to build a house, you need a foundation. So our foundation of our database there is referred as a schema. So whenever you want to create a database, you could use this. You can tap on this to create a database. So we'll be coming to that later on. So you can create a new table in your database. You can create a view. You can create a store procedures. These are our advantages of having a database. These are some advantage of database. These are some things you can do on your data that will that maybe that help you get your data for easy accessibility, integrity, and all of those advantages we've talked about on the database management system. So you can also create a function. You can create a function on in your data, in your DBMS. So it's an advantage of So what's what talking about functions? So functions, I think functions are things should not be new to us. If you've worked with Excel and like that, if you work with Excel, it should not be new to functions. So function is actually let's say command, or command that help you carry out some specific tasks. Functions that help you carry out some specific tasks you wish to perform, maybe on any applications like that. So functions, you can customize your own function. That's the advantage of having a function tab, a function ribbon here. So you can customize your own function to do whatever you want to do. So to also save your time, that's an advantage of having a function. So I guess functions should not be something new if you work with Excel. So you can also search for maybe a particular data to here. So like that. So reconnect to your DBMS. Let's say you have lost. So don't forget we connected to a particular server. So as I've said, that connection are things you would have signed while signing up to launch up this MySQL, are questions that might have been asked from you, and you have to provide, and a connection will be created for you like that. So this is where you carry out some administrative tasks. That's the management. This is the administration pane. So you can see a lot of things there: the server status, the client connection, the user privilege. So who have access to your database, and who have access, and what privilege have you granted them. You want to export your data, you want to import them. So these are just administrative tasks. So these are where you can do a lot of them. So basically our goal here is to teach you how to write SQL code, how to retrieve data from database, how to use SQL for data analysis. So that's what I'll be moving straight to. So As you need to also note that when we're talking about SQL or DBMS, so it's something that is widely used. So it's not used only by a data analyst. It is used by a data analyst. It's used by a data scientist. It's used by a database administrator. So basically, just like Excel as well. Excel, so it's not only used by data analysts. It's used by a lot of, in fact, a lot of professions, a lot of fields. In fact, even in financial model, they use Excels like that. So basically, you go there to pick what you need there. So that's how it works. So here I'll be showing you how to write code and how to use SQL to retrieve data, create data, as I've said, to perform code operation in the present to perform code operations, as I've said in the presentation. So to start with, I'll be starting with creation of a database. So this is what we'll be doing first. We'll be starting with creating of this we'll be creating a database, and after creating a database, creating a table like this. A table After creating a database, I'm going to create a table that has this information. So that is where we'll be starting from. So, and I want to beg you all to try to practice along with me. So whatever I do, so try to do it on your own as well. So let's move ahead. So first of all, we want to create a database. How do we do that? So all you just need is, okay, I'm coming to this query tab. If you don't have a query tab, you can simply add a new query tab by clicking on this SQL plus sign here. So then a new blank tab will be added in this place. So then if you look at this bottom, this is where you'll be having a message and alert of, okay, maybe how that maybe that query went fine, and maybe a error message, or maybe whatever feedback or whatever query you have. When I'm talking about query, whatever code as well you have inputted, maybe it has gone successfully or it has not. So I'm talking about running. So yeah, so we want to create a database, and that database would have this information. So that means a database and having a table that will also have this information. So how do we do that first? So to start with, the command to create a table, to create a database rather, I need to create a database first. So is to type create database, and the name of the database, so create database and give the database a name. So I can just say class db. Okay, so and now I can create my database like this, but I want to add something to this, which is if not exists. So if not exists, okay. Oh no, let me take it step by step. So let's do this first. So all you just need to do is create database and the name of your database. So just run it like that. So here is how to run a particular code or query you have imputed. So here you have you can open, look at this, you can open a script file in this. You can open a script file, that is, you have a an example is one I have here. These are scripts. These are SQL query that I have written, so I can save them as a script. So whenever I save this as a script and someone wants to bring this in, you can bring it in through here. You can, so whatever you have written down as well here too, you can as well save it here. You can save your own particular script here. So save the particular script, so the code and everything you have written down, you can save it here. You can bring in another script in through this place as well, just so you can bring it from here. So yeah, so this is where you need to know after you have written your query. So yeah, after writing create database and the name of the database, so you can have another name for your database. So I just use class db as the name of this particular database I'll be creating. So create database. So after using that, you need to be aware of these two icons. So these two icons with a flash. So this particular icon here is going to run when you click on it after writing your command or code. When you click on it, if it says it's going to run every code that is appearing on this query tab. So but when you use this one, it's going to run that particular query where the cursor is. So these two places are places where you can use to run your query. So after typing your command, you need to use one of these to run that query you have written down. So and there is a shortcut for it which I mostly use, which is control enter. When you press control enter together, it's going to run your command for you. So but control enter works for this particular running, like the one where I have the cursor. So let me make use of this one first for you to see how both of them works. So let me use, after writing this command, I'll just click on this. So after clicking on this, you'll be seeing a message saying that it has been created successfully. It has been created successfully. So you can see this was checked and create database db. So message, one rows affected, and the duration it took MySQL to create that database. So as I've said, you can use either this or this, but note this is used when you want to run all the query you have on your tab, and this one is used when you want to run that particular one where you have the cursor in. So that is that one. Okay, so after creating this database, so now this database has been created. Don't forget, we want to create a database and have this information contained in a table. Then that table will be stored in that database. So that's what we'll be doing. So after creating a database, then to see your database, you need to come to this place. You need to come to this schema. Click on this schema. When you click on schema and go click on this thing, this refresh button, click on it. So it's going to be refreshed. So when you click on this refresh button, you'll be seeing your database as part of the database listed there. So these are the database I have in my MySQL, in my own DBMS. These are the database I have. So I have different database. So this class DB is the one I just created now. So that's that. So one thing you need to be aware of is that when you look at database, you will see one is bolded. Othello training is bolded. So this is a database. Analytics with Othello is a database. Class is a database there. Class DB is the one we just created now. Invoicing is a database. Othello is a database. So Othello training is also, but you will notice Othello training is actually bolded. So you need to be aware of which one is bolded. So when you have created a database and you need to create a table to store an information like this. So that means after creating that database, you need to create a table. So and that table, where do you want to store that table? So you want to store that table in the database I have just created now. So to do that, if you want to store that information you'll be creating to store in that database, you need to use a command which is use database name, that's class db. So one thing I forgot to tell you is that whenever you write a query, whenever you write a code in SQL, you need to always end that query with a semicolon. I ended the first one with a semicolon and the second one with a semicolon as well. So whenever you want to create a table in a particular database, you need to use this command, which is use class db. So use, that's the command, then the name of database you want to use. So when I run this, so initially I use this one, so I will not be using this one again. I'll be using this one. Don't forget, this one will run whatever you have on this create tab, everything again. So if I use this one again, it's going to try to create another new database which I have created. So now I would use this one now. So I will use this one that will run only the one where my cursor is currently. So I will use this. So if I use that, something is going to occur. Something going to occur in this database now. So if I use this now, you'll notice class DB is now embedded. Is now embedded. So now what you need to understand in this board in here is that the one that is currently boarded is the database you are working on. That's the database you are currently working on. And if you look at this, if you look at below here, you would see a message that says that query I have run is successful. So now you can see it is checked. So that means, and it has switched to the class DB, the database I want to have my table in. So that is simply how to make use of a database. So create a database, the name of the database, then the name of database you want to use the name of the database you want to use. So that's that. So after doing that, so the next thing we want to do now is creating a table, the table that would have that information stored in database. So create a table, all you just need to do is, so you can just simply use enter to always to move to next line. So you can just say create table. So after create table, then you give your table a particular name. So you can just say I can just say SQL. I can say SQL. Okay, SQL class DB. SQL class DB. So that will be the name of my table that will be stored in the database of class DB. So then after that, then I'll use Control Shift. I'm going to open a parenthesis. I don't know the key for your own keyboard, but for my own keyboard it's just Control Shift 9. It's just Shift 9 rather. Just Shift 9 to add a new parenthesis. So after typing create table, the name of the database, you can use any name, then open a parenthesis. So my own, to open a parenthesis is just Shift 9. So I'm going to open a parenthesis. So you also need to open your own parenthesis there. So then I move to the next line. So in that next line, I'm going to impute the names of the columns. So in that next line, I'm going to impute the names of the columns. So let's move to our image to see what the first column we have. So we have the student's ID, their name and major. So then let me go back to my MySQL. So names of my columns in that table. The first thing is you have student's ID. Student's ID. Don't forget, you don't give a space you don't use a space when giving a name. Look at my database. I joined everything together, class DB, no space. Even look at the name of my table, no space. You are not allowed to give a space when you are giving a variable a name. So basically I'm giving a particular column a name. That's also like giving a variable a name in coding as well. So you don't give a space in whenever I want to give a variable you want to write a variable name. Either you can use an underscore and do something like student's ID. So the mandatory thing now after giving the particular name is where you now make use of this data type I briefly explained in this presentation. So you'll be making use of this data types here. Look at data types. So we have int for integer. So whenever you want to create a particular column, you want to have a particular column that contains only numbers, you have to make use of data type integer. So this is where database and maybe a spreadsheet too are different. These are where they are different, because whatever you have specified is what that database would allow whenever you try to import data to that database. So consistency is there for a database, data integrity and efficiency. Whenever efficiency is there for a database, unlike a spreadsheet too. So yeah, whatever you have specified, maybe integer, so that means in that column that table would not accept anything that is not an integer or a number for that column. So that is where that's the essence of this data type you'll be having there. So let's see how to make use of it. So we have seen integer as numbers. So yeah, since students id column, everything we have in that students id column are numbers, so that's an integer. So then after student id, I'll be specifying the data type of that column, which is int, which stands for integer. That's done. Then since that student id is also the primary key I want to use for that my particular table, I'm going to specify it. Student id int, then I'm going to type a primary key since it's the primary key of that table. Then after doing that, I can move to the next line. But before I move to the next line, I need to use a comma. So comma will be used whenever you have to list things. Whenever you have to do listing, you want to list anything, you want to have a list of particular. So you can see I'm actually listing my columns. I'm listing the names of the columns which I'm to have in that table. So then I've listed student id. So then I need to move to the next column, which is name. Then I move to major. So then I'm using a comma to separate the names of that table. So that's the next thing is name. After using name, then I'll do the same procedure I did for student id. I specified the data type and a constraint for it. A constraint. So primary key can be referred as a constraint. So constraint is like, okay, like a limitation, also. So name. So since in my table every name there is occurring in an alphabet, not in a number. It's occurring in an alphabet, not in a number. So then I have to specify the data type for it. So data type for an alphabet is simply varchar, which stands for variable character. So variable character. So varchar for storing string. As I've said, string stands for names like alphabet, text. So varchar. So then I have to come to that place and specify that, okay, my name column is varchar. After typing that, I have to open a parenthesis and specify the numbers of characters I want that column to accept. So you can just you can say 5 if you know every name of students is not above 5. But let's just say 7. No, let me just say 10. If you know every name of students is not above 10, make use of 10. So and you close the parenthesis. So I just use the name of the column, and I use varchar, that's the data type for that column. Then I open a parenthesis and provided the size of what that column should, of what character of name, the length of character of name should accept overall. Then since I have to list another column which is major, then I use a comma. Then I go to the next line. So then under the next line again, I'm going to type the next column, which is major, which is what major. Then under major, I need to check what type of data is contained in that particular column. So everything there is an alphabet, no number. So then I need to specify a varchar for that column as well. So the essence of this data type is it would not accept anything from that column that is not a text. So since I know my major, that's the department the student is in, is the spelling is not more than 15, so I'll just say, okay, varchar 15. Then I move to the next line. Since I move to the next line without adding a comma to it, since I'm done listing, I move to the next line. Then I close the parentheses I have opened initially. why list before listing this columns names. Then I close it. Then since I have to always end every code with a semicolon, then I add a semicolon to it. So and then I click on this place to run it. If you click on that, so then if you check below, you will be seeing a message that says it has been created successfully. So create table, the code, this is the code, so it has been created successfully. So you can see it has been checked there, so it has been created there successfully. Okay, so now this table has been created. So to see the table, all you just need is to, you can just come to this schema place, click on this drop down. So currently the table has not reflected in this place, so all you just need to do is to come to this place and refresh, click on this refresh. So then you'll be having that table showing in this place. So this is it. So this is the data, this is how the database I have on my MySQL. Then click on this drop down. When you click on the drop down, you'll be having things listed like tables, views, stored procedures, and functions. So when after refreshing it, you'll be seeing, then if you click on this drop down of the table, you'll be seeing the new table that you have created there. So SQL class DB. So if I click on this drop down again, then I'll be seeing something like columns of the table, then the index, maybe any index I have created. I can create index, I can create the foreign keys, I can also create a triggers on a particular table. So if I click on this drop down again, so I should be seeing list of my columns names in that table. So that's that. So and let me try to view that. Let me try to view to call out that table. So there are codes you write to view or to see data in a particular table. So all you just need to do to view a particular table or is to just type select, then star from, then the name of the table, SQL class DB. So then I end with a semicolon. So this is the code to write, okay, we want to see the data contained in a particular table. So after that, then you come to this place and run it. So you'll be seeing something coming up now to show you whatever data you have in that table. So now you can see when I use select star from class DB, so I'm seeing this thing. So here is where you see if there is any data in that table. You can see I'm only seeing the student ID, the name, the major. So that's the name of the columns I have created in that table just now. So and you can see everything is null because there is no data inserted yet. So now let's insert data to that. Let's insert data to the table we have created initially. So you just use enter to always move to the next line. So and one thing again, when you check this place, when you see this, check this place, you'll be seeing all whatever I'm running is being checked. That means it's moving smoothly. So if you have made any error, you'll be alerted in this place. So I would intentionally make a particular error for you to see that now too. So you'll be seeing an error. If once you make an error, maybe in the command, you'll be notified in this place. That's what I just mean. So you can see everything there is everything is going smoothly and successfully. So like that. So let's insert data before I intentionally commit an error here, so you can see an error message. So to insert a data in a particular table, all you just need to do is just use insert. Just type insert into, then the name of the table comes next, SQL class DB. Then you need to type values. After typing values, then you open a parenthesis and give the details, give the values, the info you want to type accordingly the way you have that columns. So we have student ID first. That's student ID 1, and the name is Jack, and the major is biology. So student ID, the first student ID there is 1. So you have to check out that data has been entered. That student ID 1, the name, the major, like that. So I'm going to impute it that same way. So we have student ID 1, name is Jack, major is biology. So I'm going to input that data that same way. So after values, open a parenthesis 1, that's then you want to type the name. Something you need to note about every programming language: whenever you want to type a name, which is referred as a string or an alphabet, you must type that name starting with a quotation. So a quotation mark, then you type Jack, then close it again. So with that, SQL will understand that what you have typed is a text or is a string or is a name. So then I use a comma. Don't forget, you are going to be using a comma whenever you are listing an object, whenever you are listing anything. I've been using a comma to list a column ID, and also use it here to list the data I want to insert. So you'll be using a comma whenever you want to list. Comma will be used for listing. That's all. So 1 comma, then the next thing is Jack, that's the name, how that data is being arranged. Then the next thing is the major, which is biology. And since biology is a text, then I have to type it starting and ending with a quotation: biology. Then I close my parenthesis since I'm done with that. Then after typing every code, you must end it with a semicolon, so that after that, then I run it. So this data is going to be inserted in that table we have created. So then we still have more data to be inserted. So let me just simply copy this line and paste it here, Ctrl C for copy, Ctrl V for pasting. So then I just edit the data inside there, then run it again for others like that. So the next one, we have student ID 2, kids and sociology. Student ID 2. So I'm just going to be editing whatever we have in this place. So student ID 2, because it's the same thing. Student ID 2, kids and sociology. Then after doing that, I'm just going to run this command like that, and it's going to be inserted successfully. So you notice I have not been having any error message, so because my query is moving successfully and going fine. So I've been having there is no error message so far. So everything there has been checked. So if you check down, everything there is checked. So let's still start one more before we see the data we have been inserting in that in our table. So the other one here is we have clear and English. Students ID 3, clear and English. So then insert into, I can just copy and paste as well, but I choose to type it this time around. SQL class DB values, then open my parentheses, then I use 3, then 3 comma, since I'm listing it now, then I use a quotation, then clear, then the major is English. Okay, so then English, then I close the parentheses and I use a semicolon to end whatever code I have written. Then I just run it here. So now I'm having a successful message that has been run successfully. So now let's try to view the data we have inserted so far. So to do that, you can just simply put your cursor here and run it here, or if you like, you retype it, whichever way is fine to you. Select star from, then the name of the table you are inserting your data to, then SQL class DB, then I use a semicolon, then I run it. So I'll be seeing that data I have inserted so far. So you can see I've created a table in that database having this data. I've entered 3 records so far. So I'm having the first student ID is 1, then name is Jack, then the major is biology. So student ID 2, the name is Kate, then the major is sociology. So student ID 3, then the name is Claire, and major is English. So like that. So that's how we can create a table and insert data in a database. So like that. So don't forget, we can also import data to database. Let's say we have large or voluminous data, maybe from a bank transaction, or from a from a very big organization transaction. You can always import them through here after a table has been created. So you just import them successfully. So like that. So let's quickly input the other the other two data we have in that table. Then we move to other ones here. So we have, so insert into SQL class DB, that's the name of the table, then value. So the next person is 4. So what's the next name we have there? We have Jack again, and biology. Can you see that this is an essence of having a primary key? Look at now, Jack and biology is occurring 2 times. So let's say you don't have a primary key. How do you differentiate Jack, biology, this first one, and this one together? How do you differentiate it? So these are the essence of having a primary key, or having any type of keys in a table. So primary key, the foreign key, they all serve a very big purpose in data analysis, and it's something you need to know very, very well. So now look at Jack and biology occurring twice. So the same information now, but now the student ID has differentiated them to be a different persons. So Jack and biology. So for Jack, biology. So that's what I actually have here again. And I just have to run it since I have changed the primary key, that's the student ID. Then I move down again. I can either type it, insert, or I just copy and paste it there, and I just change the values. Insert into SQL class DB, open the parentheses. Then the last person ID is 5. Then what's the name there? We have Mike and computer science. Ensure you are doing this along with me. Mike and computer science. Mike, we have Mike and computer science. Computer science. Mike and computer science. Then I use my semicolon there, then I run it. Don't forget I said I can use control enter, then it's going to run it for me. So that's, but for this class, so let me just simply make use of this so you get it and you don't get confused there. So I'm having a successful message. So now I can just bring my cursor down to this command and run it here. Then now I'll be having 5 data in that table. So I'm having 5 data now. So student ID 1, Jack, biology, Kate, like that, Claire, Jack, Mike. So I'm simply done with that table. So this is a starting point of knowing how to create a table in SQL. So it's really interesting to know, and trust me, it's something worthy of knowing. So let's move to the other tasks we have to do in this presentation. Our time is not actually by my side, but I pray I'm going to cover more before. Let's try to create out this database. So this one seems to be kind of complex. This one seems so far in that database I have created, or in that table, I did not include anything like a foreign key. I didn't create anything like a foreign key. So but in this one, it has foreign keys and that's primary key. So let's see how to go about tables like this. So this is what I'll be doing. Let me simply split my screen. So I'll be having this one separately somewhere. It's okay. So let me okay. Okay, so I've splitted my screen now. So let's create this. Let's create this table now. Let me show you how to create this table now, where you'll be having a foreign key and primary key together. So yeah, we only make use of only make use of primary key. So let's see how to create one with table. So to if you want to write a comment in SQL, you just need to start that sentence with two lines. So just say creation. Let me just say creation of companies companies database. Creation of companies database. So whenever you want to write a comment like this, like a comment, like comment is, a code. Comment is just like, a text that you don't want to run it, but you just want to be seeing it. You want to be seeing it on your query tab. So that's what we refer as a comment now. So so and to write that, so you just need to start that comment with two dash. So it's just going to comment that sentence, whatever you have written there, out. So now, let me make use of more of comments so you get it very well. So create table. Creation of table first. Let me just do it like that. Okay, let me say one. Create creation of table. So let's create our table, so you get to know how comments really works here. So yeah, we have in this table employee ID, the first name, like that. So we'll be creating the table just the way we created that one. So we have then you have create table. Then the name of my table will come next. That's employee. Then I open my parentheses. I move to the next line. Then I'm going to list the names of the columns. I have in that table. So the first one here, I have employee ID. Don't forget, you don't give it a space. Employee ID. Then employee ID. I hope you all have the copy of, you should have screenshotted this company database somewhere. You can screenshot it. So this is what I'm actually working with. So you don't get confused what I'm working with. So this is the table I'm creating. So I'll be having employee ID, the first name, the last name, the birthday, and like that. So first we have the employee ID. Let me place it here. So employee ID. I don't want to zoom it over. Okay. Employee ID. So an employee ID is actually an integer. Yeah, an integer, because everything we have in that column are whole numbers. They are numbers. So we want that employee ID should accept. The essence of having a data type, it's going to make our data to be efficient. Not that database would know. I don't know if you know how crucial data is to every business now. So every business now, every bigger business, or every business at all, whether small or whether big now, would never want their data to be manipulated, or whenever they need it, and they have to discover a lot of errors from it. So they have to ensure that every data their employee is storing from them is storing the right data, because that data is needed maybe for reference purpose, and a client could come in next 100 days to come and claim for certain things. So, and they need that data they are keeping to be genuine. So that's the essence of having a data type. So data type would ensure that that's why they try to import that particular data. Okay, I haven't made an error. Okay, after creating this, I'm going to make an error to try to put in a wrong data type. Try to input a text where I'm supposed to input a number. So you will notice it will be rejected. So it's going to alert me. So data type help to reduce errors. So it will not be funny when a company needs data of 100 years back, and they have to get to that data, and they discovered errors, different type of mistakes from different workers. It's not really going to be funny. And let's put ourselves in a case whereby this organization really need that information to make a particular claim to make a particular claim. So that is that's a very big risk for that business already. So these are the essence of having a data type. So I'm going to intentionally make a particular error. I'm going to make a particular error. So let me make this error trying to impute a particular data in that initial data table we have created. So look at this. So then I want to intentionally make an error. So you see the essence of having a data type here. So let me bring this. So let me impute one more data in that table we created initially. So I'll move to insert into. So I will intentionally make a particular error so that for you to know what the essence of what a data type is doing for us there. So I want to insert another data to this one we have. So to be making 6. So values. So now I'll be, instead of, I'm supposed to have so I'm inserting data into this. So in case I'm inserting data into this, I'll be having another one now. So instead of, and the first column now, I'm supposed to have a student ID. So let me make a mistake. I'll make a blunder and try to put a name there. Try to put a particular name there. So that's let me just say Otelu. Otelu. I'm having a name there. I'm supposed to have a number, that's a student ID. Then I use a comma. Then here I came here now and I'm not putting the number here, 6. Then I'm moving. You can see whenever I want to write a text, I'm starting and ending with a quotation mark. It's very, very necessary. So then for the major, I'm now imputing the right thing. I'm not saying echo. That's my department. So then that's my major, the department. Okay. So then I'm closing it. So I've made an error here. So definitely I'll be having an error message here. So and it will not be accepted. So this is the advantage of what having a data type while creating that table or creating the column rather. So if I run it now, I'll definitely be having an error. You can see this is an error which I intentionally made. So you can see say incorrect integer value. So in that first column, the student ID, it will be expecting nothing but a number. So and the place where it's expecting an alphabet, you must not type anything exceeding that size you have provided initially. Don't forget, when creating name, I gave it the virtual size of 10, then major 15. So like that, whatever is exceeding these characters, that's the spelling. When you spell 1 2 3 ABC like that, when you count it, the length of that character, if it's exceeding this size, it's still going to be rejected. So these are the essence of having a data type while creating a column of a table in SQL. So so I intentionally made this error. So now to correct this, all I just need to do is to take away Othello in that student ID, put my 6 there, then I put Othello in the proper place. So then I say okay Othello. You can input your name as well. So then I run it now. So I will be having any error message here. So now I have rearranged it to the proper way now. So if I try to view that, if I come to this place to that select from the name of the table, then if I run it here, I'll be seeing Othello as part of the data I have in that table. So now I have Othello and echo, then student ID 6. So one thing again you need to know about primary keys is that let me try to input one more information for you to see what the primary key is also doing there. So if I come down to this place, and I try to make use of a primary key, okay, let me type it manually so you can so you don't get confused. So I want to input another information to this. Insert into SQL class db values, then I open my parentheses. So now I want to make use of a student ID that has been used, and the primary key must not have the same ID for different things. So you need a unique identifier. So because I have stated that column, that student ID, to be a primary key, it will not accept an ID that has been assigned to someone again. So these are the essence of having a data type. So now 5 has been assigned to Mike. Let me try to make use of 5. Let's say unknowingly unintentionally, I try to give someone the ID that has been used, or that has been assigned to someone in that database. So which is 5 has been assigned to Mike. So let me give it another name. Let me give it a name. So let me just say, okay, Sunday. Let me just say, okay, Sunday. Then okay, Sunday. Then I said, okay, then that Sunday is for the name. Then the major is, let's say, IRPM. Then I close my parentheses. Then I use the semicolon. Then I run it. I'll be having an error message simply because 5 has been assigned to Mike. So, and that ID has been assigned to a particular person, and you must not have a duplicate ID for different things. So that's the essence of a primary key. So primary key is going to help you, differentiate every unique data you have in your table. So even if it's up to millions and billions, it's still understandable and it's analyzable. So with a primary key, every data, no matter the volume, it is safer. So I hope that was clear. So can we just move forward to this table creation we were creating? So we are trying to create this particular table and trying to implement the for you ID in this creation as well. So I'll be creating these two tables, the employee table and the branch ID table. So that's what I'll be creating. Then you can just go and practice how to create other ones on your own. So it's still going to work the same way. It's still going to work the same way. So create table employee. So we have employee ID. So here the employee ID here serve as the primary key. Rather. This serve as the primary key. So it was uniquely identifying every data in this table. So then I will specify that, okay, it's a primary key. Then I use a comma because I'm listing my columns there. So then I have the first name. Don't forget, you cannot give it a space. So then the data type, which is virtual. Then let me just say the first name, size, all of them, they are no more than 20. So that I'm giving it 20. Then I'm using a comma. So yeah, I want to add something again to this, which is referred as a constraint. So in the first thing, I can specify some constraint, like saying, okay, every name you should accept in that first name column should be unique. So that means it's not going to be accepting every name that has been accepted before. No, in that first name column we would not be having any double names, just like here where we'll not be having Jack and Jack occurring. So maybe you've known the name of every employee, none of them is having the same name. So, and you don't want any employee to move there mistakenly and try to tell me two different employee bears the same name. So these are ways to as I've said, these are data types and constraints to help you reduce errors of storing your data in that database or a table. So let me use a constraint which is unique. So then the other thing we have there is last name. We have last name. So it is a text virtual. So let's say everything is no more than 25. Then I know all of my employees, all of them have a first name and a last name. So I can make a constraint here which is simply not null. So that means it would not accept any record you try to input and you are trying to leave in the last name null. So that means not null would ensure that while they are inputting the data in that table, there must be a last name for that employee. We don't want a null. That's what we want. That's what we mean by not null. So yeah, the first one we have unique. In all of that column, every name there must be unique. Not null. There must be a last name for it. We don't want, there must be no no cell under the last name that is empty or that is null. So these are constraints trying to reduce errors. So comma, I move to the next line. So then we have the birth dates, then I come there, right? birth dates So then I'm going to specify that what you should accept there is a date. So it is what? Date time, then comma. I might give it a constraint not null or not. I move to the next one. Okay, I'm okay with just birth date and date time. So the next one, what do I have? I have sex and salary. Okay. I have sex. Okay, sex. So yeah, I'll be using a data type which to specify everything I want to have under sex, which is enum. Enum is the short form of enumerate. So yeah, I'm going to be using enum. Don't forget sex. Since everything I have under sex are text, I can make use of varchar, but I want to be more specific. So I can make use of varchar and I input varchar 1. I can do this varchar. Varchar 1. So I see every text character there is not more than 1. It's not more than 1. So it's just 1. So it's not going to be accepting anything that is more than 1. But I want to be more specific. So I'll be using enum. Open the parentheses. So I use a quotation and specify whatever I want to have. Instead of having M and F, I want to be having male and female. So enum quotation male, comma, then another quotation female. So what I've done here is I use enum male and female. So what I've done here is that it's not going to be accepting anything that is different from male and female. So if it is M and F I want, I could just put M and F with a quotation like that. So then comma to the next line. Then salary, we have salary again. So then salary is simply there is simply an integer because we're having a whole number there. Salary, then I have to specify it's an integer. So now I want to use another constraint here, which is what? Default. Okay, I want to have a default salary. Okay, let's say for example, let's say there is a particular employee that is not paid. Maybe we already know that in our organization that maybe while trying to pay our employee, some of them don't receive the money. So we want to have a default message, instead of having something blank, or having null. I want to have a default thing that says something like not that says okay, this employee did not receive any money. So after int, write a default and say even if this person is not paid, this is the message I want to get. This employee did not receive money. Then I end it with a quotation like that. This employee did not receive money. Then I use a comma. So this is the message I want to have. If that person is not paid, instead of having a blank message, I want to have the employee did not receive money. That is done. Then I have the other keys. I have the other column, which is the foreign key, the super ID and the branch ID. Let's create that one as well. So we're having super ID. What we have there is an integer, right? So I'm not using a constraint here. So then I have a branch ID. branch ID. What we also have there is an integer. Then I moved, since I'm done, I move to the next line. Since I'm done, I move to the next line. I close my parentheses and I use my semicolon. Let me make all of this. Let me start with small letter. Okay. Okay, let me leave it that way. Okay. So now, create table, the name of my table, the column name. I'm listing all the columns I will be having there. The column's name, employee ID, the first name, the data type, and giving it a particular call strings I want to have. So like that. Then after that, I just come to this place and run it. Oh, invalid default value for salary. Oh yes, we'll be having an invalid default salary simply because, don't forget, I have specified my salary to be an integer, so it's not going to have anything that is text, so I try to give it a default value of this employee did not receive money. So the default value I can have for an integer column is simply 0. So I would have made use of I would have made use of such default for a voucher. So I can just you can make use of such default value for a voucher. Let's say, for example, last name. Now I could just have, instead of not null, I could have default. If there is no name for that last name, just tell us that this employee do not have. Okay, let me try to bring in middle name and show you how to make use of that middle name. So that I'll use that there, middle name. Don't forget, we don't have a middle name in that table, but I'm actually bringing it here so you can see how a default value works in that manner I try to show you. So middle name, we have, let's say we all know how the middle name here is. Is no more than let's just say 17. Then after that, then I would say default, then my default message. So if the employee do not have a middle name, just tell me, instead of saying no, just tell me no middle name. Then I use a comma, so then everything is fixed that way. So then I run it again, then it has been created successfully. So now I've created a table. So let's try to view our table. Let's try to call our table. So we use select star from employee. So the name of my table, employee. So then I run it and see the table I have created. So I'm having a table created with null. I'm seeing all the columns there. The way I have arranged it like that. So don't forget, super ID and branch ID were foreign key. So I have not made them a foreign key. I already created the table. And don't forget my definition of a foreign key. A foreign key, before you can make a key to be a foreign key, it must have been a primary key of another table. So that means I have to, before I can make this a foreign key, you can see branch ID was used as a foreign key, super ID, which was an ID picked from here. So this super ID is on its way. So I need to create a branch table as well before I can make branch ID foreign key. I could move on to move super ID a foreign key directly here, but let's do it together. Let's create a branch table first so we can make both of them a foreign key at once. So we need to create a branch table. Don't forget, a foreign key is another table primary key. So branch ID was used as part of the foreign key in that table we have created. So we need to create branch table before we can make branch id a foreign key in that table. So then let's create branch table. So the same method, create table, then SQL, okay, branch, let me just say branch t, okay, that's for our branch table. So then open my parentheses, I move to the next line, then I input the first column we have in that branch table, which is branch id and branch name. So then branch id, and what we have in the branch id is actually integer. So, and branch id there serve as a primary key, so I'm going to input the primary key here. Primary key, I move to the next line. Branch name, I have voucher, and the branch name since it's a text, that's why I'm using a voucher. So branch name, that voucher, then I'm going to give it a size. Let's say I know the branch name is no more than 20, so maximum of it. So then, and I know every branch has a branch name, so I don't want to have a null when you try to give me a branch name, trying to give me insert branch id. So then comma, since I'm listing the name of the column. So then the next thing I have the manager id. Then manager id there is an integer, and it's also a foreign key. But I need to create that column first. Then we have the manager start dates. Manager starts dates. So then I'm going to make it as a date time. Then I move to the next line. I close my parentheses. So I close my parentheses. No, before closing my parentheses, I can do something here. Before closing my parentheses. So since this code would create me a table with 4 columns: branch id, branch name, and manager id and manager start date. So already, if you check this table, I have a foreign key, and the foreign key is the manager id, making reference to this particular employee table which I have created earlier. So since I have created that table, then I can go ahead to make this manager id a foreign key right from the creation of this branch table. So then I'm going to make the manager id here a foreign key. So I'm going to use a comma now, since I still have other things to type underneath. So I'm going to type foreign key. I open my parentheses. So I'm going to put in the name of the column that is a foreign key as this in this branch id. Name of the column, the manager id is the foreign key there. I close the parentheses. So manager id, how it has been spelled there. Then I'm going to use this keyword reference. Then what is this manager id looking up to? What is the reference like? What is the primary key? Since a foreign key must have a primary key, so where is this one primary key? So this is actually the foreign key. So when you see a manager id here 100, so it means David. When you see manager id 102, it means Michael. When it means manager 106, it means Josh. So that means this is actually looking up to this primary key, this employee id here. So then I will say reference that employee table. Don't forget the initial table I created, the name was employee. Then the name of the table, reference the name of the table, then open my parentheses and specify the exact column that manager id is referencing. So that is employee id, EMP-ID. That is how I spelled it there. So I need to go and confirm if I'm typing exactly what I have there. So because I must type exactly if you are starting with a capital letter here, you must start exactly what is there. So employee ID starting with a capital letter, then employee here all through in small letter. So you have to type exactly how it is, how you have spelled it there. So employee, then in opening parenthesis, I'm going to specify the name of that column. The name of that column that manager ID is looking up to actually. Then after that, then I can move to next line, close my parenthesis. Don't forget I have opened a parenthesis for creation of this table from the beginning. So I close the parenthesis, then I use a comma, I use a semicolon rather, then I can run it at this place here now. So if I run it here, then it has been created successfully. So now upon creating this branch table, I have made manager ID a foreign key like that. So that's that. So after creating that, so and with that again, I have created the branch table. So I can try to see my branch table which I have created. Select from branch T, then I run it. So I'm going to see that table. So it's not going to be more than 4 tables, but now manager ID here, manager ID now is a foreign key. The branch ID here is a primary key. There are places you can see those details of where one is a primary key, one is a foreign key at this database. But let's finish up what we are doing currently. So now I have created a table. Now since this branch ID has been created, this branch table has been created. So now don't forget my manager, the employee ID I created, the employee table I created then, the employee table I created then as the foreign key which have not been included. So now just because I don't have this table yet, so now since I now have this table, then I can now make that initial table, that employee table, that's this one. Select from employee. I can now make, so I'm using a shortcut to run it, Control Enter if you don't want to come here to click. So then don't forget when I created this table, super ID and branch ID were foreign key, which I have not made them a foreign key simply because I don't have a branch table yet. So because this foreign key branch ID is referencing this branch ID primary key in the branch table, though this supervisor ID is referencing this one. So I need to have this table created for this branch ID to make it a foreign key. So since I have created my branch ID, then I can go ahead to make this employee table a foreign key now. So then to do that now, don't forget you have created that table already. So to do that, you need to now make use of this DDL command again, which is alter. So I want to alter a table that has been created before and make changes to it. So I'm going to make use of this keyword, which is alter. So then alter, then you'll be needed to provide the name of the table you want to alter now. Alter employee. No, alter table. Alter table. Then the name of the employee. Then you move to the next line. Then you say add modifier. It's not going to be add again because this table has been created. This column. Basically, what I want to do, I want to make supervisor ID and branch ID a foreign key now. So since I have created that column when creating the employee table, I just want to make it a foreign key now. Then all I will do is to modify it to make it a foreign key. Then I will not be using the keyword add. I'll be using modify column. So then the name of the column I want to modify, which is super ID, exactly how it has been spelled. So super ID, modify super ID. Okay, so it's not going to be modifier, it's going to be adding. So as I've said, so since since that table has been the super id and the branch id column was created and it was not made a foreign key, so then I need to add the foreign key, not going to be modified, sorry. So then add a foreign key, alter table, then the name of the table, then add foreign key, then specify the name, which one you are making to be a foreign key there. It is super id, the super id, close the parentheses, then reference same employee table, then open the parentheses, then employee id just the way it has been spelled there, close it, then I end it with my semicolon. All you just need is to run it. So when you run it, you'll be having a successful message like that. So, and that has been made a foreign key. So the super id is done. So then I need to do the same thing again for branch id again. Alter table again, employee, then add foreign key, branch id is the foreign key that I close my parenthesis, then references, then the name of the table where you'll be having the foreign key, employee, open the parenthesis, then what is the referencing? No, it's not employee, it is the branch table. Now it's referencing the branch table. Don't forget this one is looking up to this is the primary key here, and it was picked from here. Why this one is looking up to this one there? That's why we did not add it as a foreign key then. This table will be adding. So that's the branch T. That's what we have named that table initially. Branch T. Then what is it looking up to there? Branch ID in the branch T table. And I close it. I hope it is spelled the same way. So then I run it again. Run. Then I'm having a successful message. So then both of them has been, so both super id and branch id has been made a foreign key here, like that. So let's see, okay, how to be sure of what kind of key you have made a column, what kind of, what are the constraints behind a particular column in a table. So let me quickly show you. So I've created two tables in a nutshell here, the branch id and the let me try to call them out before we go to there. Select from employee, so control enter is going to call out. So nothing will change in that table, but there are where you can check what type of constraints and integer you have selected for that table. Select from branch T, so I'm using control enter instead of coming here to click on it. So just like that. So how are you sure that we want to be sure of the constraint, the data type used for the creation of that table? So before you have to come to this schema where you have, so all you just need to do, if you want every change of every code you have run so far that has been successful since to reflect here, you have to come here and refresh. So when you refresh, so you can just click on the drop down of your database. Don't forget, all of these tables we are creating are stored in a particular database, which is class db, which we created initially. We created a database initially, so class db. So all of these tables, we have created three tables now, which was stored in a particular database, which is class db. So if you check the drop down of the table, we have the three tables there, the employee, the one we just created now, and the branch T, the two tables we just created now. And don't forget, we created one initially, SQL class DB. So That's what making it 3. So now let's say you want to be sure, so when you click on the drop down of the database you are working on, is the one that will be currently encoded. So you would see tables and the list of the numbers of tables you have in that database. So we have employee, we have branch, we have SQL class DB. Let's say you want to see, what and what cost rate has been assigned to a particular column. So when you try to click on the employee, you'll be having 3 icons there, 3 icons. So click on the middle icon that has something like a spanner setting. So click on it. So if you click on that thing, you'll be, so I'm clicking on that's the setting of employee. You'll be seeing this. Then these are the information about that database, that table that was created. So to see the constraint, just click on this, click to change the number of display available table option. Click on this, then you'll be seeing this thing there. So now if you come to this place, you will see a lot of things you have assigned to that particular table. So you can see employee ID, the first name, the middle name. So you will notice data type int, pk, which stands for primary key, was checked, not null. So first name, the data type, you can see uq, it stands for unique, was checked. That means it's only accepting a unique name, and the default expression is that if you don't input anything for that first name, it will be having null. So if you go to middle name, varchar, the data type, you can see none of this was checked, nothing was checked. It's not a primary key, it's not a not null, it's not uq, that's unique, it's not it's not null, it's not nothing. So, and the default expression, let's say you didn't put anything there, you'll be having no middle name for it. So you can just come to this place and see everything like that. So birth date, so the birth date, the date. So if nothing is imputed, the default expression is null, it's nothing at all, nothing was checked for it. So we also have sex. So we have sex, male and female. So we also have the salary. The default expression, let's say nothing was imputed for the salary, they were not paid, just we'll be having 0. So to know if a key is a foreign key and a primary key here, so if you check this employee ID, there is a yellow key in front of it, so that represents a primary key. So now when you move to the other place where we have a foreign key, you will see this kind of something like a kite. So both of them, just the super ID and the branch ID is like that, and with different colors like that. So that's a foreign key. So the same thing, you can go to the branch ID and click on the spanner too, so and see that's the setting, and see the setting you have made for that table. So that is that. I want to believe I have really explained that so far. So we need to move ahead, and for me to also show you some other things. There are really a lot of things you can do with SQL, creation of table, retrieving of tables. So let me try to insert data here and show you some other things you can do with SQL. So then we'll end it for today. So let's insert data. In now. So I want to insert data into the branch ID. Don't forget, I have the branch ID columns. Okay, let me come here and run my branch table. I just want to run it, so I have run the branch ID. So I'm seeing the order of how my branch table is has been arranged. So I can input data there. So branch ID, I can say insert the same way, insert into branch insert into branch T, values. Then what's the branch ID? The branch ID is simply the branch ID is 1, and corporate branch. The branch ID there is 1, and we have a quotation. Don't forget, corporate branch, corporate. Then don't forget, the next thing we have is a foreign key. One thing about a foreign key is that if just like when creating a table that has a foreign key, once the table for that primary key for its primary key is not created, you cannot have a foreign key. So now the same way that goes is the same way. Once a value has not been made a primary key, once a number, now we're talking about the value now that will be there now, like 100 has not been assigned to a particular employee, you cannot make use of it as a foreign key. So but then in that situation, then I need to insert a value for the manager ID, and we don't have an employee yet. We don't have any employee yet, but now we are trying to have a branch and we don't have an employee yet. So what we simply do is simply put null there, because something must be inserted in that manager ID, and because we don't have a branch, we don't have an employee yet that has any number that has been inserted in that employee table. So I just have to use null so as to insert this data. So then I will use my start date, that's 2006 to 9, 2006 to 9. Okay. So one thing again, when you're inserting a date in SQL again, you are going to insert it like you are inserting a text. So use a quotation mark, 2006 02 09. So then close my quotation, I close my parentheses, I end it with a semicolon, that, and I run it. That's done now. So let me try to bring that data. Let's see what has been inserted. Select into, no, sorry, let's call it select from run it. So now corporate branch has been inserted and I'm having branch ID as null. So let me input one more before we move to employee. Insert into branch values. So the next person we have 2, and I think it's not Scranton. We have the Scranton branch, and we don't have an employee yet. We are still going to be making use of Scranton. So since no employee yet, null. Then what's the manager start date? The manager start date, we have 1992 and 1992 0406. Then I run this again. So it has been inserted that way. So I move to this place again, I run it until data have inserted. So I've inserted 2 data, so that's 1, 2 and 3. Let me quickly finish up this instantly. Then let me just finish up this. Let me copy and paste it for this one. Oh, sorry, I made a mistake. Copy, then I'm moving here and pasting it down there. Okay, so yeah, I'll change this to 3. Then what's the branch there? We have Stamford 1998 023. Stamford. O2. Then we have 3. Am I correct? Okay, 0213 rather. 13. Then I run it. So now I have successfully inserted the 3 data we have in the branch ID. So then I can go ahead to insert data in the employee ID. So that's the data I have inserted so far. So the branch ID, the branch name, the manager ID, simply because there is no employee yet, I'm having null. Then the start date. So then we move to the employee ID, the employee table. employee, select from. I usually like to call out the table I want to insert so I can see the order of it. So control enter to run it, control enter. So that's that. So I'm seeing the order of that employee ID. So then now I can insert data into this. Insert into employee. Then I'm having a values. So before I go straight to insert data properly, I will intentionally make an error for you to see how unique work. I need to insert a particular. Let me insert let me make it right first. Then I want to show you how all those constraints are used while creating these employee tables works. So then the first employee ID here is 100. That's 100. David Wallace. So okay, that's 100. The name is David. Then we have don't forget you can as well use your name as well. Okay, now so the middle name, I brought in this middle name myself, so I'll be adding my name Othello. Then I move to the next line, then Wallace. So don't forget we brought in the middle name ourselves. So then we have that's the birth date. What's the birth date here? Where's the birth date? 1967 11 17. 1967 11 17. Then is a male. So in this sex, don't forget I will specify an enum that don't accept anything that is not male and female. So let me make a mistake and put males. So don't forget that's an error already. Males instead of male. So males. Then the salary, I intentionally made that error. Let's see if it's going to be accepted. Don't forget I used a constraint like enum, male and female. That's what you should accept. Then a super ID here, I can have null since nobody's supervising David. That's fine. Then branch ID. So don't forget branch ID is a foreign key. So I can insert this branch ID 1 simply because I have inserted corporate branch. I have inserted corporate branch when I was inserting data in the branch table. So that branch, the primary key is already there. I have the primary key, so that means I can make use of it in that employee table as a foreign key, and it will work successfully. But don't forget, I have intentionally made an error here. Of typing males instead of having male. Don't forget I specify enum, male and female. So here I should be having an error message because of these males I have specified here. So yeah, so I'm getting an error. Can you see columns count does not match the value at row 1? So there I just have to take away the s instead of them making it a male. So it's actually the constraints that is working there now. So here it should go successfully now. Still an error. Okay, let me check where that is coming from. Count error. We have insert into employee values. We have 100 David Wallace. So we have male. Let me view my column and see what I'm having. Okay, we have employee ID 100. First name is David. We have middle name as Othello. Then last name, birth date. Oh, sorry, I have omitted salary. That is why. So it is not complete yet. So I will still make that same error I wanted to make then. So after birth date, there ought to be salary. I didn't input salary. Sorry. So that's 250,000. It's not the one ending the highest. 250,000. After birth date, there's a salary of 250,000. So I think that is correct now. So it's now correct this way. So then don't forget I have made an error here. Males instead of male. So I will still be having an error. So data truncated. It said data truncated for column 6 at row 1. tetrahedron here for column cells. So it's simply because of this s I have added. So if I take away this s now, because it's only accepting males, it has to be, whatever you have typed exactly. So yeah, if I run it now, it should go in successfully. Coming. Oh, still a mistake again. The arrangement. Okay, so this is where you need to be or observe what you are doing very well. So there's the mistake again. Here's the mistake again. Sorry, I didn't arrange. So it was sex before the salary. It was sex before the salary. So I made a mistake. Sorry, it was sex before the salary. So after birth dates, we have sex. So that error is still going to be made again, because so you can understand this better. So males. Okay, so now after birth dates, that's what I like to view my columns. I like to view out my columns and see how it has been arranged. If I'm not inputting that data the way it has been, the columns are arranged, I will always be having an error. So that is always a must. That's a must. So then I have employee ID, first name, the last name, the middle name, the birth dates, the sex. So I've inputted x, then the salary, the super ID, and the branch ID. So if I run it here, I'll still be having an error just because of the males. Yes. So now let me take away this s away now. Then I run it now. It should go in successfully now. So that's fine. So now can you see that? So when you are typing a string, you need to type an exact string that you have typed. That is one thing about programming language. You don't type exact string that you have typed initially. That's how it works. So that's how things you have typed. So let me just let me type one more again. I'm still going to make more blunders so you can so I think in the first name I specified unique. Okay, was it in the last name? Let me check. Was it in the last name? I specified unique, so I cannot violate all of those rules I have stated while creating. I specified unique for the first name, and middle name should be no name if nothing was inserted. Okay, now I'm going to edit. I've copied this code here and I'm pasting it here. So let me say employee 101. I'm leaving it as David again. So yeah, in this for the middle name, I'm just going to put a default value. Just going to put a default. Don't forget the middle name. I have set it to be no middle name once nothing is inserted. So to use the default value, you just have to type default in the middle in that middle name. In that middle name space, so put default there. So now I'm leaving the first name as David. So I want to intentionally make that error. So yeah, look at Wallace. Simply because the last name was not set to unique, that will not be the cause of the error. So yeah, then let me change this month to 1990. Let me say female. Let me make use of female. At this point now, I cannot make use of F or M. Because of what I have specified. So here I cannot say 110. Let me just say 110, and I'm having null. I'm having so now what is the super ID? No, I'll not be using null again. So the super ID is actually 100. That's David. So for this super ID, I'm saying 100. That's David. Then I run this. So if I run this, I'll be having an error because I'm having a duplicate entry for David. For the key. So don't forget, when I was creating the first name, I made use of a constraint which is unique. So unique would not accept the same name that has been used or like that, just like the way primary key works. So it now accepts similar names or similar IDs and so on like that. So the error is from here. So I just have to just come here and change this to, okay, let me just say Yakub. Then I run it now. Then it is successful. So now if let me view the employee details, let me call the employee. I'm coming to this employee place and run it. Control enter. So now I'm having 101 Yakub, no middle name. That's the default value I've given to nothing is inserted for middle name. Then Wallace is, you can say I'm having the same name repeated here simply because I didn't set it to not null. I did not set it to unique. I already set it to not null. So you just needed something there. I think that's clear and so like that. So one thing again you need to understand about foreign keys is that, let me insert one more data then before we can also move to other, before we can update. Okay, move to next thing. Insert into employees. So we have 102, then the name, I must use another name, hope you know. So then let me just say hope. Let me just say hope. Okay, then let's just say default. Okay, then let me change this name here. Let me say Adam. Okay, then I'm not following the data we have there again. So let's just say 2000. Then let me say 2017. 29. 05 29 quotation comma, then let me say mail. So then let's say the person is earning 50,000. So now let me show you one thing about foreign keys here now. So now foreign keys, don't forget now it's time for me to insert the super ID, which is a foreign key. Now I want to show you, I want to insert a value that has not been made a primary key, and let's see if it works. So don't forget, the super ID is referencing on the employee ID. It's referencing on the employee ID. So let me try to use let me insert 106 for that, for 103. When we employ 106 that has not been created, that has not been employed, and let's see 106, and we have let me change this branch to 2. That's the Scranton branch. 106 has not been employed. We are still at 102. So now if you run it, it's not going to work, simply because 106 has not been employed. So that's because it has made a foreign key. So it needs a relation that from a particular table and to another table. So one thing about database that you just need to tell DBMS that this one is related to this, then it's going to be doing the link up. You don't need that. You don't need to do that. So instead of that, even if you don't want to make use of an employee that has been employed, you can just simply use null and come back to update it later. So let's just say 100. Let's see make use of David again and run it. So then it's going to go in successfully. So then let me come to this place and view the employee table. Then we now have an employee that is in the branch ID Scranton 2. That's Scranton branch. That's 2, no more 1 again. So I think that's pretty easy to do. So that is done. So now don't forget, in the branch ID, in the branch table, while we were inserting data, we made the manager ID null. So let me view the branch table back again. We made the manager ID null simply because we don't have a super ID yet. You made it null. So how do you now? So now, since you have made it null, and now we now have an employee ID. We now have an employee that has been employed. How do you update it? How do you correct it now? So let me insert one more employee. Okay, no, let me start one more employee. Then we'll come back to update. We'll come back to update the manager ID in the branch ID. So I'm 103. Then let me just say okay. Let me say okay. Sunday. You can use any name you like. So let me change this one from default value. Let me just use another name. Okay. Bio. Okay, I can still leave here as Adam. Then I can change it to 2018. Let's make it of a female. Then we have 52,000. So let's say this one is working in the is working in the in the Stanford branch. That's 3. Then this supervisor ID is 102. That's up here. So then I run it. Then let me view it before we come back to the branch table. So that has been inserted like that. That's been inserted. So we now have 4 details there now. So now let's go back to our branch ID now. And so the branch ID, don't forget, while creating it, we made employee ID, the manager ID node. So now let's update it, since we now have employees for that could serve as the manager ID of that branch there. So then all you just need to do, you need to make use of this command, update branch T, update the branch table. Then you say set the MGR ID, this MGR ID to 101. Move to the next line. Then you can see where branch ID is equals to 1. So update this particular table, set the manager ID to 101, then where branch ID is equals to 1, come to this place and run it. So that's done. So if I view my branch table now again, that place has been updated successfully. So 101. So like that. So it's the same procedure for the rest of them like that. So update again, update branch T, set MGR ID 102, where branch ID is equals to 2. Then run it. I use Control Enter. So then the last one, updates. We have updates branch C, set MGR ID equals to 103, where branch ID is equals to 3. I use the semicolon, then I run it. So that's done. So if I come to this place back, the branch table, then I run it again, then I will see all this data updated. So that's pretty how to create and how to create table and database in SQL. It's actually pretty easy. All you just need is consistent practice. How to learn, open to learning. If to become a data analyst, you need to be ready to and be open to learning. So I think I'll be stopping yet for this class. So I'll continue more. I'm going to take SQL another step further in my next presentation. So put in, and I would love to have your comments in the comment section. So the reviews and how far and what you have learned, whatever questions you might have, just put it in the comment section below. I'll be glad to attend to them. So please subscribe to the YouTube channel so for more videos. Thank you.